Hey everyone, this is Tarab, and on our team we have Anuba and Caleb. The title of our project is Hospital Charge Data Analysis. The motivation behind the project was to come up with a useful tool for patients to know their medical expenses prior to receiving healthcare. For our project, we came up with a platform which helps patients sort out the hospitals by cost, analyze the cost for DRG groups, and list down the distance for a selected hospital. The dataset we are using contains information on the cost of a DRG for a specific hospital.
A DRG is a diagnosis-related group. Patients with similar diagnoses frequently require similar treatment and incur similar charges.
Using the dataset, we were able to calculate the average charges for each hospital. We also computed the average charge for all the hospitals in the dataset. Using this information, we were able to compare the selected hospitals to the national average. Users are able to look up the hospitals by putting in either name, city, zip code, or region. We wanted to create a search so patients could look up a specific symptom and determine the cost of a care. We calculated the maximum, minimum, and average charge for a specified DRG. Users can look for a DRG to determine their treatment cost. We also calculated the distance of the user to the selected hospital. The hospital that is chosen was the one that had the least charging for the DRG.
Much of the data analysis we accomplished involves reducing data into simpler terms and removing data that is no longer useful. This can often be a cyclical process. We are able to key off a specific value to group matching data for calculations. For example, as we calculate average charges for each provider, we were able to sum and average values using the provider ID. To find the maximum, minimum, and average charges for each DRG, we were able to key off of the DRG number. This data set represents about 7 million separate charges for a total of about $246 billion. Our analysis reduced over 163,000 lines of data to 100 lines of data for DRGs and 3,337 lines of data for providers. The average patient charge was $35,000.
In order to integrate our project, we created a front-end user face using HTML and JavaScript. It contains links to our programs that determine the hospital listing by cost, the listing by DRG, and the listing by distance. The first program we created allows a patient to search for a specific hospital based off the location. We created a text box for the user to type in their search. When the desired hospital is selected, it returns the name of the hospital as well as the percentage of how much the hospital differs from the national average.
This percentage was calculated as the hospital average minus the national average divided by the national average. A negative percentage signifies a below average cost. A positive percentage signifies an above average cost. A percentage near zero represents charging close to the national average.
Additionally, we created another search that allows the patient to search on a specific diagnosis-related group. Here is the interface if a user hasn't entered in any information. In order to further explain our functionality, we'll provide an example. If the patient has bronchitis, but there are no major complications, the patient can simply look up the word bronchitis in the DRG search. The DRG search returns the least a hospital charged with the selected DRG, the most, and the average charging for the specific DRG. So the least charging for bronchitis is $3,113.76. Our second scenario is a patient who has a heart failure with a comorbid condition, meaning that they have another disease or disorder in addition to the heart failure. The DRG search returns the least, most, and average charging for the DRG. Here we show the distance and driving duration between the patient and the hospital with the least charging rates for a patient with a heart failure and a comorbid condition. We had to make some decisions when creating our project. For one, our program did not calculate the values in real time because we had a consistent data set. A more elaborate program would have recalculated these values for each user. We also did not adjust the prices for inflation because the numbers for inflation are not consistent and would change with time. We used Excel to manipulate the data, JavaScript and HTML to design the user interface, and a Google Distance Matrix API to design the map interface.
If we were to improve upon this project in the future, we would use a dataset with more DRGs. This only had the most common DRG. We would also use a dataset that has more insurance information rather than just Medicare. We would elaborate upon our DRG search and look up to make it more precise. We would sort the hospitals by closest distance to the user. Additionally, we would make the listed DRGs specific to the ones that the hospital offers. Lastly, we would develop the user interface further.
Be sure to post any questions. We hope that our work here will be helpful in developing future tools to keep patients informed and involved in their care.
We hope you enjoyed our video. Thank you for listening to our project demonstration.